In this video, I'm going to be describing the imaginary unit using operations with complex numbers, writing complex conjugates, and then finding complex solutions to quadratic equations. The imaginary number I is defined as I squared equals -1, and therefore I equals the square root of -1. Again, because if I squared equals -1 and you're to take the square root of both sides, then you will get the equation I equals the square root of -1. Now, in the past, you have learned that you cannot have the square root of a negative number, which in this case, why they've denoted by an imaginary symbol. So, for example, the square root of -4 can be written as the square root of -1 times the square root of 4, which would be the square root of 4 is 2, and the square root of -1 is the imaginary number I. So the square root of -4 is 2i. The square root of -8 can be written as the square root of -1 times, the square root of -8 can be written as the square root of -1 times the square root of 2 times the square root of 4. If you were to break it down, the square root of 4 is 2, the square root of -1 is I, and then you're left with the simplified square root of 2. So anytime you have the square root that you can simplify, the negative means go ahead and bring out the I, and then you're looking for any perfect squares that go into this number, which would be 4 times 2 in this case. Square root of 4 is 2. The negative means you'll bring out an I, and then the square root of 2 is left underneath the radical. Now, the powers of I actually follow a formula. I to the 1 is the square root of -1, which is I. I squared is basically taking I and squaring it. Now, I is the square root, and the square root and square of themselves cancel each other, leaving you what is on the inside of the radical, which is -1. I cubed is I squared times I, because remember, when you multiply, you can add exponents. 2 plus 1 is 3. So we know that I squared is -1, and we know that I is just I. So -1 times I is how we get -I. Next, I to the 4th we can rewrite as I squared times I squared. 2 plus 2 is 4, which is already do that. Well, we know that I squared represents -1 from up here, and I squared also represents -1, and -1 times -1 is a +1. Now, if you're to look at I to the 5th, I to the 5th can be written as I to the 4th times I to the 1. Well, we know I to the 4th is 1, and I to the 1 is just I, so I to the 5th is actually just I again. I to the 6th can be written as I to the 4th times I squared. I to the 4th we also already know is the number 1, and we know that I squared is the number -1. And so 1 times -1 is -1. I to the 7th can be written as I to the 4th times I cubed, because 4 plus 3 is 7. We know that I to the 4th is the number 1, and we know that I to the 3rd is -I. 1 times -I is just -I. So if you notice, a pattern follows. I to the 1 and I to the 5th represent the same answer. I squared and I to the 6th represent the same answer. I to the 3rd and I to the 7th represent the same answer. And then I to the 4th and I to the 8th would represent the same answer. So the powers of I actually create a pattern of every 4th pattern it is going to repeat. So if you think about things in terms of multiples of 4, you can be able to find the answer. So if we were to divide 21 by 4, 4 goes into 21 perfectly 5 times, and your remainder becomes your power of I in order to find it. And so I to the 1 is just I. So I to the 21st is the exact same answer as I to the 1st. So if we were to do I to the 93rd, how many times does 4 go into 93 perfectly? Well, 4 goes into 9 2 times. 9 minus 8 is 1, bring it up to 13. 4 goes into 13 3 times. 3 times 4 is 12, and we're left with 1. Whatever your remainder is, that is again what is going to become your new exponent, and the 1 means it is just I. Complex numbers are written in the form of a plus bi, to where a and b are real numbers. So for example, 3 plus 5i is a complex number. 3 plus 0i is technically a complex number. I mean, it's the number 3, but it's technically, you can write it as a complex number. Or 0 plus 10i is a complex number. 0 minus 2i is a complex number. 4 minus 10i is a complex number. For example, we can simplify this to become a complex number. First, this is the real part, and this is going to be our imaginary part because this has a negative square root. The real part comes first, so I'm going to go ahead and write negative 8. Now we got to figure out what this is going to be. So the square root of negative 20, well, we know that's going to be I square root of 20. So we know that first because negative inside the square root means there's going to be an I. Now you want to split this into what perfect number, or what perfect number goes into 20? 4 and 5. You can't use 10 and 2 because neither one of those is a perfect square. 4 is a perfect square. The square root of 4 is 2. So we are going to get 2i, because 2 is a whole number now, I is out front, and then we're left with the square root of 5. So negative 8 is considered our real part, and then 2 square roots of 5 is considered our imaginary part. Now you can graph complex numbers. Again, if you think about the first number being real and the number with the I is going to be imaginary. So 3 minus 2i means you would go over to a positive 3 and go down to the negative 2i, and you would have your coordinate point. Negative 5, 3i means you would go negative 5 on the real axis. You would go a positive 3i on the imaginary axis, and that would actually be your coordinate point. You can add complex numbers. The first thing you'll need to do is distribute the 2. So you get 4 plus 3i, and then 2 times negative 5 is a negative 10. 2 times negative 2 is a negative 4i. And now you can combine like terms. Negative 10 and 4 give you a negative 6. 3i and negative 4i give you a negative 1i. And that is how you would write your complex number. You also can multiply complex numbers. So 4 times a negative 2 will give you a negative 8. I times I is going to give you an I squared. But you cannot stop there because you just learned that I squared is actually the number negative 1. So your final answer is actually a positive 8. In this case, you would FOIL. So 5 times 3 would give you 15. 5 times I would give you a negative 5i. 2i times 3 would give you a 6i. And then 2i times I would give you negative 2i squared. Combine like terms. Negative 5i and 6i give you a positive 1i. Now in this case, you need to simplify this part because we know that I squared is the number negative 1. Negative 2 times negative 1 give you a positive 2. And so now you can combine 15 and 2 to get 17. In this case, you do not just square the 3 and then square the 2i. This squared means you need to take the parentheses and you need to write it twice. And now you will FOIL. 3 times 3 will give you 9. 3 times 2i will give you a 6i. 2i times 3 will also give you a 6i. and then 2i times 2i is going to give you a 4i squared. 6i and 6i give you 12i, but we're going to simplify the 4i squared. I squared is actually the number -1. 4 times -1 is a -4, and you can combine 9 and -4 to give you a +5 plus 12i. Complex conjugates. The conjugate of a complex number of a plus bi is going to be a minus bi. You don't switch all the signs, you only switch the sign in front of the imaginary number. So for example, if you want to simplify a fraction that has a complex number in the bottom, what you will do is you're going to multiply that denominator by its conjugate, which means you just switch the sign in front of the imaginary number. And whatever you multiply on bottom, you must multiply on top. So on top, you're going to distribute 5 times 3 is 15, and 5 times 2i is 10i. On bottom, when you FOIL, you'll get 3 times 3 is 9, 3 times 2i is 6i, negative 2i times 3 is a negative 6i, and the negative 2 times negative 2i is going to give me a negative 4i squared. Something nice happens in this case. The two middle terms should always cancel, and then you can simplify the last term. You get negative 4, but I squared itself is negative 1. Negative 4 times negative 1 is a positive 4, which means you can combine 9 and 4 to get 13, and on top you're left with 15 plus 10i. And that is how you would simplify a fraction that has an imaginary number in the denominator. You can also find complex solutions from equations. So for example, because there's only one term that has an x, we can solve for x by subtracting 100 from both sides and then dividing both sides by 4, and we get negative 25. To solve for x squared, we would take the square root of both sides because a square and a square root cancel, leaving me plus or minus. Remember, anytime you take the square root of something, you got to do plus or minus. And the square root of 25, negative 25, well, the square root of the negative is going to give you an I. And the square root of 25 is 5. So you can either leave it like that, or what you would normally see is the real part is going to come first in front of the I. So it would be the square, the plus or minus 5i. In this case, you would subtract x squared on both sides to get common terms together. 3x squared minus x squared gives me 2x squared. Plus 1 equals a negative 1. So to solve for x squared, I'm going to subtract 1 from both sides to get negative 2. And then I'm going to divide by 2 on both sides. I get negative 1. To solve for x squared, I'm going to take the square root of both sides. When I do, I'm left with x equals plus or minus, and the square root of negative 1 is the symbol I. So to find all the zeros of this term, there's a couple ways we can do this. So first, you could try to figure out what possible zeros you could have based off of the rational zeros test. So all the factors of 36 divided by 1. Or you could also go ahead and see if you can factor. This actually factors. You would have x squared and x squared, because x squared times x squared gives you an x to the fourth, and when you combine x squares, you'll get an x squared. So you can actually do the big X here. What multiplies to give you negative 36 and adds to give you a positive 5. And the answer is 9 and 4. It needs to be a positive 5, so 4 must be negative. So I'll get x squared minus 4 and x squared plus 9 to give you 0. So this actually factors, or actually you could solve both of them. X squared minus 4 can give you 0, and on this side you can get x squared plus 9 can give you 0. So you would add 4 to both sides and get 4. Take the square root and you'll get plus or minus 2. So you know that 2 and negative 2 are going to be two of your zeros. Over here, I would subtract 9 on both sides. But when I take the square root, I'll get plus or minus the square root of a negative 9. The square root of 9 we know is 3. But the square root of a negative is where we would get an I, which means 3i, and a negative 3i are going to be my other zeros. And those are my 4 zeros of finding all the zeros of this polynomial. Another way you could have done this is you could have done synthetic division to find any possible rational zeros, which we did find is 2 and negative 2. So you could have done the synthetic division. But then you're going to get down to something that you cannot use synthetic division for, and you will have to solve it algebraically at that point.